Hi, my name is Grasiela Martini. I am professor at the Federal University of Rio Grande. I would like to thank the organizer for the opportunity to speak about this work, a method for the calculation of a whole partial action of a Hopf algebra on its ground field and some examples. It's a joint work with Antonio Pax and Leonardo Silva. I will start with the definition of a partial action. A let partial action of a Hopf algebra H on an algebra A is a linear map satisfying three conditions. These three conditions. A is also called the partial H modular algebra. In the case of a Hopf algebra H acting on this ground field K, we have a bijective correspondence between a partial action and a linear map lambda in H star satisfies these two equations, this and this equation. Hence, the map lambda is a partial action of H on K with and only if lambda of B is a solution of a partial system associated with B. This system 2, where B is a basis of H. In particular, the partial system associated with B always has at least one solution, the global action given by the counit, right? So to determine all partial actions is to determine all solution that system. However, solving this system is hard because it has n square solutions. Our goal is to find a method that facilitates these calculations. For this, we will need to follow results. First, we will denote the group of group-like element by G of H, right? Let lambda be a partial action. Then for any group-like element G, lambda of G is 0 or 1, and set group-like elements G such that lambda of G is equal 1 is a subgroup of G of H. If lambda is a partial action, then lambda of B is a solution of the following system. The first and the second equation always hold due to the previous results, right? The third equation holds for all group-like elements G such that lambda of G is equal to 1. Then we will reduce to find the solution of the last equation for the elements in base that are not like elements. So we can separate this system into parts. Denoting lambda of B by lambda index B, or alpha index B, alpha B, is a solution of this system 3, if only if alpha G is equal 1, alpha H is equal 0, and the other elements are determined by 3 parameters. In this case, the system tree always has a solution, and we call it on an initial and condition. On the other hand, fixing a subgroup N of G of H, we can define these equivalence relations, right? Then we can reduce the initial system for the other equivalent system for call it of the n-reduced partial system associated if B. Therefore, we have the following result. Consider the group G of H and extended it to a basis of H. And lambda is a linear map. Then lambda is a partial action of H on K if only if N, this N, is a subgroup of G of H. And lambda of B is both an initial and condition, and also a solution for the system for. Therefore, to obtain a partial actions of H on K, we perform the following steps. Step 1, extending G of H through a basis B of H. Step 2, consider N a subgroup of G of H. Step 3, regard the solution alpha B of the system tree. Step 4, investigate the n-reduced partial system associated with B, system 4. Therefore, each solution of the step 4 is a partial action. Now, we have some remarks. First, for step 4, is useful to determine if alpha B can be a solution of system 4 or not. 2, since every partial action of H on K has an initial condition, we apply the method to all subgroups of G of H. Then we obtain all partial actions of H on K. I present now all the partial actions of the 18-dimensional pointed non-semi-simple Hopf algebra H. These are 5 Hopf algebras in this case, right? In particular, we find all partial action of this Hopf algebra. The method. Step 1. These are the group-like elements, and this is a base of H. Step 2. We note that group-like elements has 3 subgroups, this, and this. When the subgroup is the group itself, we obtain that lambda is a global action in this case. When subgroup when n is 1 and G square, by step 3, we have these elements. These elements. Not that we have 2 free parameters in this case. For step 4, so due to equivalence relation in the n-reducible partial system associated has 8 equations, right? We get this 8 equation. Clearly, alpha B is a solution of the system above if only if the two free parameters is equal. And the last case, by step 3, we have these elements. And now by step 4, the system 4 has 3 blocks of H equation each. Doing some calculations, alpha B is a solution of this system if only if we have these 2 equations in this case. Then all the partial actions are given in this table, right? For the other 4 Hopf algebras, we have the following partial actions. This, and this. The method and the partial action of the 16-dimension point-end non-semi-simple Hopf algebra H are part of this work already submitted to a journal. Right. And here are some references. Thank you.